Hello scientific people of standard 8th, welcome to DAV Moyle Public School. Now, we will continue with the concept of sound. In previous video we have studied about sound, what are sound, different types of wave. Now in this video we will study about different characteristics of waves. Now let's begin. Now what are characteristics of wave? Previously we have studied about waves. There are two types of wave, transverse wave and longitudinal wave. Sound waves are longitudinal wave, whereas light wave are transverse wave. Longitudinal waves travel parallel, wherein the particles travel parallel along the direction of wave, whereas transverse wave, the particles are in perpendicular direction along the direction of wave. These are the certain things we have previously covered. Now let us understand some more terminology about wave. The wave is characterized in terms of following parameters: phase, amplitude, frequency, wave velocity, time periods. These are certain characteristics of a wave. So let's see what is phase. Now, as I told previously, this is a wave. So the portion from point A till point E is considered as one wave, and from point E till point J is considered as one wave. From point E till point O here, that is I, is considered as a one wave, and A till E is considered as one wave. Now, all points on a wave which are in same state of vibration are said to be in a same phase. Now, for an instant, as you can see, this A, E, this is A portion, this is a, and you can say this is a three wave: first wave, second wave, or rather two waves. First, this is the first wave which is starting from A and ending at E, and a new wave that is starting from E and ending at I. So there are two waves. Now if we analyze this two wave properly, we will find certain things common. Now in this two wave we will see certain what is exactly do you mean by phase. Now for an instant, if a particle which is residing at point A, E and I, so the direction of vibration would be in same direction. As you can see, a particle is about to about to start from its mean position. As you can see, in again at particle at point E, the particle is in the same direction, and again at point H or again at point I, particle is in the same direction as that of E and A. At A, E and I, all particles are in same line of motion. Whereas in a similar manner, B, F and J, this is the B portion, particle is going in downward direction. B, F and J, all particles are going in a downward direction. So that is another phase, and A, E and I is one phase, B, F and J is one phase. In a similar manner, C, G and K, this is the C portion, C, G and K. At point C, particle is trying to go in downward direction. C, G, again at point G, particle is going in downward direction, and at K, it is particle is going in downward direction. So all the particles which are going in downward direction at point C, J and K are in same state. Whereas D and H, D is located over here and H is located over here. Particle is trying to move in upward direction. So that is one phase. So one phase. So there are certain phase. As you can see, in short, the phase, all point in a wave are in the same state of vibration. As I told, in this wave there are many phase. So all the phase which are in same state are considered as a one phase. Now amplitude. Now again, if we consider this as a wave, now amplitude is the maximum displacement of a particle from its mean position. So this line is known as its mean position. So when a particle is going, the maximum displacement which is happening from the mean position and the highest point where the particle is reaching, so that height or rather that distance is known as amplitude. This is the amplitude. This is a wave displacement from its mean position, that is the amplitude. So this A portion, the distance from mean position till over here, that is amplitude. In the similar manner, distance from mean position till this portion is considered as amplitude. Same here also, here also. Now, the amplitude of a wave is the height of the crest or the depth of a wave. Previously, I told this portion, since we are talking about transverse wave, so it would be considered as a crest. When we talk about sound wave, it would be considered as a compression, and this would be rarefaction. In case of transverse wave, this would be crest and this would be trough. So distance from the mean position till maximum crest is considered as amplitude. In the similar manner, distance between trough till mean position is considered as amplitude. Now, amplitude, since it is a length measuring physical quantity, it is measured in meter. Amplitude is simply a length which is measured from main position till the crest portion over here. It is measured in meter. SI unit, that is standard international unit of amplitude, is meter. Now, second thing, what is frequency? The number of waves produced per second is called a frequency. Now, this entire thing previously I told, this is the starting point and this is the ending point. So this is considered as a one wave. So the n number of waves which can be possible. So the number of waves which can be produced in 1 second, that is a frequency. Or you can even say the rate of which waves are produced by a source. As you can see, one wave is being produced in 1 second. This was the initial position and this was the end position. One wave is being produced, so the frequency of this wave is 1 in 1 second. If another wave was there, and again the time period was 2, we have to simply calculate number of waves upon time. That will give frequency. Now, frequency, it is denoted by symbol V or F, or it is even denoted by nu. More precisely, we don't use V for a frequency, we use nu. V is written in terms like this, a nu, which is pronounced as nu, or you can even say F. F stands for frequency. Now, wavelength, as the word itself speak, wavelength. Previously, I told wave is from this position until this position. This is considered as a one wave, and another wave would be starting from here and ending at here. So, the wavelength. So, what is exactly the length of a wave is considered as a wavelength. Now, the distance between this is if I told this is a crest portion, this is one crest, this is one crest. When we talk about transverse wave, so the distance between this crest and this crest is length, or the distance between this crest to till this crest is termed as wavelength. In the similar manner, distance between trough from this trough to this trough is known as wavelength. Now, the entire wavelength is of lambda and it is denoted by the symbol lambda. This is the symbol, a line is there. This is the symbol which looks like wavelength, and we say this sign as lambda. It is a Greek word, and if the entire wave, if the entire wavelength is from this point to this point and we name this as lambda, so the half of lambda would be lambda by 2. So the distance from this point to this point will be, it is clearly understood, it is lambda by 2. In the similar manner, if the wavelength from this trough to this trough is lambda, so half of that portion would be considered as lambda by 2. Half of this wave is this, so this line indicates it is lambda by 2. Now, some more characteristics of sound. Now, what exactly do you mean by sound? Pitch. Pitch, it is the sensation of frequency of an emitted sound. Now, it is a sensation of frequency. How a frequency is being produced, that is a pitch. Now, pitch, as you can do, as we know previously, frequency is number of wave which is produced in a time. So the different types of frequency which is produced give rise to pitch. The sensation of frequency, how the frequency gives sensation, that is a pitch. The frequency could happen in this manner, where the waves are highly compact to each other, whereas frequency over here is apart. Two types of frequency are happening. So when this distance between two waves is at a apart distance, we will say it is a low pitch sound, whereas whenever the frequency where the wavelength is very less, we will say it is a high pitch sound. Now, high pitch sound are also known as shrill sound. So this is the high pitch sound. It is known as shrill sound. Example of shrill sounds are hummingbird, sound of a guitar. These are high pitch sound. Now, pitch sound. This is a low pitch sound. This is a low pitch sound. Now horse sound, roar of a lion, car horn. This is a low pitch sound. Low pitch sound. The waves look like this. Now, second thing, that is loudness and a softness of a sound. Now, loudness and softness of a sound, again, it is related to the amplitude. It depends upon the amplitude. Previously, I told this is the mean position of a wave, and the maximum displacement from its mean position determines whether the sound is of loud quality or a soft quality. If the amplitude is more, the distance between main position till the crest position, if the distance is more, we will say it is a loud sound. As you can see, this is the mean position, and if the distance is exactly over here, so the distance is maximum over here. As you can see here, the distance is minimum. Yes, as you can see, this distance is minimum and this distance is maximum. So this is a loud sound, whereas this is a soft sound. Now, intensity of a sound. Intensity of a sound is how strong the intensity of a sound is. We can calculate with the help of simplest formula at this point of time. We will understand intensity at higher level. At straightforward level, intensity, it is a sound energy upon time consumed into area. What is the area of that instrument where the sound is being reflected, and the time consumed upon sound energy, so that we can calculate intensity of a sound. Timbre. What exactly do you mean by timbre? In music, timbre means timbre. It describes the quality or the character of a sound voice. As we know, we as a human being are characterized into two parts, male and female. Female voice is different, male voice is different, cat voice is different, dog voice is different. So the quality of a different species is known as a timbre. The timbre helps your ears to distinguish between two different types of sound. Example, sound of a cat from your sound of your dog. So there are two different sounds which a human can hear properly and recognize that this sound is of dog, this sound is of sound. In a similar manner, this sound we can realize that this person is a male and this person is a female. So that is nothing but a timbre. It is also referred as tone color or the tone quality. So we can even use the words or the terms like tone color or tone quality for recognizing sound. I hope you have understood the concept. Thank you and have a nice day.